In this video, we'll be discussing 10 different types of questions from the chapter Arithmetic Progression. Be thorough with these problems so that you won't lose even a single mark from the chapter. So let's get started. This is the list of questions that we'll discuss here. So let's begin. The first question is, find how many two-digit numbers are divisible by 7. Let's see. Which is the first two-digit number which is divisible by 7? The first two-digit number perfectly divisible by 7 is, we know it is 14. The next number is 21. Then it is 28 and so on. And which is the last number perfectly divisible by 7? That is 98, the last two-digit number. Okay, so this is our sequence. So we got the value of the first number, that is 14. Then what is the common difference? Common difference perfectly divisible by 7. Therefore, they will be separated by 7. The common difference is 7. D is 7. Okay, so we know the last term is 98. So we have to find how many digits are divisible by 7. That is, we have to find n. We know the last digit divisible is 98. So when we know the nth term, we can find the value of n. A plus n minus 1 into d. 98 is equal to first element is 14 in the sequence. Then n minus 1 into d is 7. Substituting all the values, we'll get it as 14 plus 7 n minus 7. So the number of terms perfectly divisible by 7 is 13. Now the next question is, find the 20th term from the end of the AP given as 3, 8, 13 up to 253. So let's consider the AP in reverse direction. So considering the AP in this direction, we have the first term as 253. So we'll take the last term as the first term because we are counting from behind. We have to find the 20th term from the end. That's why we are taking the AP in reverse direction. So A is 253. Now the common difference is 5 from the beginning. But when we are taking in the reverse direction, D becomes minus 5. Now we will apply the formula for the 20th term. A plus 20 minus 1 into D, that is 253 plus 19 into minus 5, that is 253 minus 95. This will obtain 158. So this is the 20th term from the end. The third question is, find the sum of first 40 positive integers divisible by 6. Also find the sum of first 20 positive integers divisible by both 5 and 6. So the question is divided into two parts. Let's see the first part. In the first part, we have to find the sum of 40 positive integers. So n is equal to 40. We have to find the sum of 40 terms which are divisible by 6. So which are the first positive integers divisible by 6? The first positive integer is 6, which is the next positive integer is 12, and so on. So these are the integers, first positive integers divisible by 6. So A, the first term of the series is 6. Now each term divisible by 6 will be 6 digits apart. That is, the common difference is also 6. Now let's find the sum. Sum of n terms is given as S of n is equal to n by 2 into 2a plus n minus 1 into d. We know the value of each variable, so we will substitute. N is 40, a is 6, n is 40, d is again 6. So we will get it as 20 into 12 plus 39 into 6. The value obtained is 4920. Okay. Now, what about the second part? In the second part, we have to find the sum of 20 positive integers. Therefore, n is equal to 20. Now, the integers have to be divisible by both 5 and 6. So, the LCM of 5 and 6 is 6 into 5, that is 30. Those numbers which are divisible by both 5 and 6, which is the LCM of 5 and 6, that is 30. So, the number has to be divisible by 30. So, the series is written as 30. Next number divisible by 30 is 60, and so on. So, what is the common difference? The common difference is 30. D is equal to 30. Now, let's find the sum of 20 terms. S of n is equal to n by 2 into 2a plus n minus 1 into d. That is 20 by 2 into 2 into 30 plus n minus 1 is 90 into d is 30. That is 10 into 60 plus 19 into 30. The value obtained is 6300. Okay. If the sum of first 7 terms of an AP is 49 and the sum of 17 terms is 289, find the sum of n terms. Now in this question, sum of 7 terms is given as 49 and the sum of 17 terms is given as 289. We have to find the sum of n terms. Sn have to be found out. So let's see. We'll substitute 49 in the expression for sum of 7 terms. 49 is equal to 7 by 2 into 2a plus n is 7. So 7 minus 1 is 6 into d. So that is 14 is equal to 2a plus 6d. That is 7 is equal to 2a plus 3d. So this is one expression. Now the next is S17. S17 is 289. 289 can be given as 17 by 2 into 2a plus n minus 1, 16 into d. Again cancelling, we will get 17 into 2 is equal to 2a plus 16d. That is 17 is equal to a plus 8d. So we have two expressions. We'll solve. Let's take the difference. 10 is equal to 5d. Therefore, d is equal to 2. Now substituting the value of d in expression number 1, we can find the value of a. 7 is equal to a plus 3 into 2. That is a is equal to 1. So we have found the value of d and 1. Now let's write the expression for Sn. Sn is equal to n by 2 into 2a plus n minus 1 into d. Substituting n by 2 into a is 1. So 2 into 1 plus n minus 1 into d is 2. Therefore we have n by 2 into 2 plus 2 n minus 2. That is n square. Now the next question is, if the ratio of the sum of first m and n terms of AP is m square is to n square, show that the ratio of its mth and the nth terms is 2m minus 1 is to 2n minus 1. So the sum of first m terms is to the sum of n terms can be expressed as m square by n square. This is given in the question. The ratio of the sums of first m terms and first n terms can be given as m square is to n square. So let's expand. What is the expression for the sum of m terms? M by 2 into 2a plus m minus 1 into d. And the sum of n terms can be written as n by 2 into 2a plus n minus 1 into d. Okay, that is equal to m square by n square. Now let's cancel the similar terms. M gets cancelled from both sides, n also gets cancelled. Therefore we have 2a plus m minus 1 into d by 2a plus n minus 1 into d equals m by n. Okay, now we'll cross multiply and expand. N into 2a plus m minus 1 into d, that is equated to m into 2a plus n minus 1 into d. Opening the brackets and expanding, 2an plus mnd minus nd is equal to 2am plus mnd minus md. Okay. Now cancelling the similar terms from both sides. Okay, we have, so let's write two a minus d into n, or 2an minus nd is equal to 2am minus md. That is 2an minus 2am is equal to n minus m into d. 2a is taken out, n minus m. That is d is equal to 2a. Okay, this is what we obtained by opening the brackets and simplifying. Now let's express the ratio of mth and nth term, am by an. This is the ratio that we have to prove as this. No? So let's substitute a plus m minus 1 into d is 2a by a plus n minus 1 into d, that is 2a. Okay, so cancelling a from all, we have 1 plus m minus 1 into 2 by 1 plus n minus 1 into 2. Let's open the brackets, 1 plus 2m minus 2 by 1 plus 2n minus 2, that is 2m minus 1 by 2n minus 1. So we have proved that the ratio of the mth and nth terms is 2m minus 1 is to 2n minus 1. Next question. If the sum of n terms is equal to n square, find the 10th term. So let's see. In order to find the value of n, let's substitute a value for n. Let's substitute n is equal to 1. So Sn can be given as n by 2, 1 by 2 into 2a plus 1 minus 1 into d, that is n square. What is the value of n square for n is equal to 1? It is 1. So 1 by 2 into 2a is equal to 1. That is, we'll obtain the value of a as 1. Okay, when we substitute n is equal to 1 for sum of n terms, we get the value of the first term, a is equal to 1. Now let's substitute another value, say n is equal to 5, s5. s5 would be n square, therefore 25. That is equal to n by 2, 5 by 2 into 2a plus 4d. We know the value of a, it is 1, therefore 2 plus 4d. That is equal to 25. So cancel in 5. 10 is equal to 2 plus 4d. We'll obtain the value of d as 2. Okay, so the value of d also we obtained and the value of a also we obtained. So let's find the 10th term. A 10 is equal to a plus 1 plus n minus 1, that is 9 into d 2. So the value will be 19. So the 10th term of the sequence is 19. Next question. Find the sum of 3-digit numbers which leave the remainder 3 when divided by 5. 5. We know that the first three-digit number which is perfectly divisible by 5 is 100. So in order to leave a remainder 3 when divided by 5, it should be 3 more than the perfect multiple. 100 is a perfect multiple of 5. Therefore, the considered number should be 3 digits more than the perfect multiple. So we can write it as 103, which is the next perfect multiple divisible by 5. It is 105. So in order to leave a remainder 3, the number should be 3 more than the perfect multiple. Therefore, the number is 108, and so on. Now, which is the last 3-digit number which is perfectly divisible by 5? We know that it is 995. So we need a remainder 3. Therefore, we add 3. Therefore, the last digit of the sequence is 998. So we have obtained the considered AP, the required AP, 103, 108, and so on, and the last digit is 998. So this is our required arithmetic progression, where 103 is the first element, 998 is the last element, and the difference is 108 minus 103, that is d is equal to 5. Now in order to find the sum, we need to find the number of terms in the sequence. In order to find the value of n, we know that the last term, or an, is equal to 998. So let's substitute a plus and minus 1 into d. A is 103 plus n we don't know, d is 5. So 998 is equal to 103 plus 5 n minus 5. Therefore, n is obtained as 180. Okay, so therefore there are 180 terms which when divided by 5 we will get a remainder 3. Now in the sequence we know the value. Now we have obtained the value of a, d and n. Now let's find the sum of all the terms. Sum is given as n by 2 into a plus l. This is another expression for the sum when we know the last element of the sequence. Okay, so let's substitute. N is 180 by 2 into 103 plus 998. So sum is obtained as 90 into 1101. That is 99090. So this is the required sum. Next question. If the pth, qth and rth term of an AP is x, y and z respectively, show that x into q minus r plus y into r minus p plus z into p minus q is 0. Q is 0. We are given that the pth element is x. So let's write AP, that is A plus P minus 1 into D is X, and AQ is Y. Therefore A plus Q minus 1 into D is equal to Y, and AR is equal to A plus R minus 1 into D is equal to Z to 0. Let's start from the LHS. LHS is given as X into Q minus R. We can substitute the value of X. X is A plus P minus 1 into D, that into Q minus R, plus Y. Y is A plus Q minus 1 into D, that is multiplied with R minus P, plus Z is A plus R minus 1 into D, that's multiplied with P minus Q. So let's open all the brackets. I'm expanding. Q minus AR plus PQD minus DQ minus PRD plus RD. I'm expanding this term. AR minus AP plus RQD minus DR minus PQD plus PD. Now we'll expand this term, plus AP minus AQ minus plus PRD minus DP plus QD. So have we got all the terms? AP minus AQ plus PRT minus RTQ minus DP minus DQ, plus DQ plus DQ. So when we open the brackets, this is what we get. Now let's see. Let's cancel out the similar terms. Plus AQ minus AQ minus AR plus AR plus PQD minus PQD minus DQ plus DQ minus PRD plus PRD plus RD minus RD minus AP plus AP minus plus DQR this is minus DQR minus DQR plus PD minus PD. So all the terms cancel out, hence. Next question. A contract on construction job specifies a penalty for delay of completion beyond a certain date as follows: Rupees 200 for first day, Rupees 250 for second day, Rupees 300 for third day, and so on. If the contractor pays a penalty of Rupees 27,750, find the number of days for which the construction work is delayed. Beyond a certain date as follows: Rupees 200 for the first day. So 200 for the first day. Therefore, the first term of the AP is 200. 250 for the second day. 300 for the third day, and so on. If the contractor pays a penalty of Rupees 27750, find the number of days delayed in the construction. Okay, so the first day fine will be 200, second day it will be 250, third day the penalty will be 300. So this is our AP. with A will be equal to 200. And what is the value of common difference? Common difference here is 50. And the total penalty paid by the contractor is 27750. So this is the sum of all the penalties of all the days in which the work was delayed. So the total amount of penalty paid is equal to the sum of the progression. Now we have to find the number of days the work was delayed. We don't know the value of n. Okay, so we have to find out the value of n. Now let's substitute in the expression for sum. Sn is given as n by 2 into 2a plus n minus 1 into d. Let's substitute the value. 27750 is equal to, we don't know the value of n, we know the value of a, so substituting, plus n minus 1 into 50. N by 2 into 400 plus 50 n minus 50. Okay. When you simplify, the expression becomes a quadratic equation given as n square minus 7n minus 111 is equal to 0. Solve this equation, you will get two roots. N is equal to either minus 37 or plus 30. So we know that in the question the value is the number of days in which the work was delayed. So we will take only the positive value, that is n will be 30.
Next question. A man arranges to pay a debt of rupees 3600 in 40 monthly installments, which are in arithmetic progression. When 30 installments are paid, he dies, leaving 1/3 of the debt unpaid. Find the value of the first installment.
He pays the amount in 40 installments and the total amount he has to pay is 3600. So the sum of all the 40 installments is Sn is 3600 and n is 40. So S40 is 3600. Okay, what else is given in the question? After paying 30 installments, he dies. And what is the amount left behind? The amount left behind is 1/3 of the total payment. 1/3 of 3600 is 12,200 rupees. So this is the amount. So 1/3 of 3600 is 1200 rupees. So what else is given in the question? After paying 30 installments, the man dies, and what is left behind? 1/3 of the installment is left behind. 1/3 of the installment is 1 by 3 into 2600, that is 1200 rupees. So this much is left behind, all the rest was paid. So how much was the paid amount? 3600 minus 1200. This much amount he had paid in 30 installments, that is 2400 rupees he had already paid before he died. He had already paid an amount of 2400 in 30 installments. So the sum of 30 installments is 2400. So you know the value of S40 and S30. Now let's substitute in the expression. S40 can be given as 40 by 2 into 2a plus 39d. We don't know the first installment paid and the common difference between installments. So a and d we don't know. We know only the value of n plus 29d. Okay. So this is the next expression. These two are the two expressions. So 180 is equal to 2a plus 39d. This is one of the expressions. Now substituting the value of S30, 2400 is equal to 30 by 2 into 2a plus 30 minus D, that is 29D. Again cancelling 80, so 160 is equal to 2A plus 29D. These are the two expressions. Now when we take the difference, we get 20 is equal to 10D. That is D is equal to 2. So now we obtain the value of D. So substituting the value of D in any of these expressions, we'll substitute in this expression. So 180 is equal to 2A plus 39 into 2. On simplification, we get the value of A as 51. Okay. So the value of the first installment is 51. 51 rupees is the first installment paid by him.
If you like the video, please do like, share and subscribe to my channel. Thank you.